Hi everyone, in this video I'm going to talk about question 17 and question 18 for Gauss Contest 2024, grade 7. So question 17, a circular spinner is divided into 12 identical unshaded sections and 3 identical shaded sections as shown in this graph. Each unshaded section is 3 times the size of each shaded section. An arrow is attached to the center of the spinner. The arrow is spun once. What is the probability that the arrow stops in a shaded section? So as we know that the probability of an event equal to all the favorable outcomes over all outcomes. In this question, the favorable outcome would be that the arrow lands in the 3 shaded sections at the end. And all outcome would just be all sections. So 12 unshaded sections plus 3 shaded sections. But since each unshaded section is 3 times the size of each shaded sections, so if I combine these 3 shaded sections together, their area would be equivalent to 1 unshaded section. So 3 shaded section is equivalent to 1 unshaded section. And the denominator will be 12 unshaded section that doesn't change, and this 3 shaded section would also be converted into 1 unshaded section. So the fraction would be 1 unshaded section and 13 unshaded section at the bottom. So the fraction would be 1 over 13. So D would be the right answer. Question number 18. The Gauss ball factory assembles robots. Each robot comes in one of 3 colors, red, blue, or green. Each robot also has a number stamped on its head, 1, 2, 3, or 4. The nth robot assembled is the first robot to have the same color and the same number as the previously assembled robot. What is the greatest possible value of n? So if we want to make sure that n is as large as possible, we need to think about the worst case, which is to say, we need to make sure that the amount of non-repetitive assembled robot is as large as possible. So how many different combinations we could get from 3 different colors and 4 different numbers? So we can see we can have red 1, red 2, red 3, red 4, blue 1, blue 2, blue 3, blue 4, green 1, green 2, green 3, green 4. So for each color, there are 3 colors. For each color, there are 4 different possible number stamping. So there are in total 12 different possible combinations. Since we need to think about the worst case to make sure that the n is the largest possible value, we can assume that for the first 12 robots, each of them is different than each other. So we used up all the different possible combinations. So at the next, which is the 13th robot, no matter what combination of color with stamping it takes, it would be the same as one of the previous model, because we are all the possible models are included in this 12 different combinations. So the 13th robot would be the first one to have the same color and the same number as one of the previously assembled robot. So the greatest possible value of n equal to 13. So C would be the correct answer. Thank you for watching.